Hi there, welcome to Unit 2, and in this lecture we're going to be talking about trees. So first we're going to see what is a tree, which is a data structure which allows for representing hierarchical relationships. In this case, we have two different mathematical expressions. In both of them we have the same elements, but representing different operations. The first one is A times B plus C times D, so we can establish some relations. In this case, A times B is represented with the association with the times operator, C times D, and then both of those results have a relation with the plus symbol. The next example, even though they are the same elements, this time the operation is A times B plus C times D, so the relationship changes. B and C are related with a plus operator, and then that result together with A and D with the multiplication. So now we are going to see two different kinds of trees. The first one are feed trees, which are a special type of graph which are connected, acyclic and undirected. So just to remember a little bit, the distinction with graphs is that they, for instance, can have direction, path can be one way, another way, or bidirectional, like in this example. Also, they can have cycles, which means we could be looping on this path, and it could be connected or unconnected. That means that all nodes have a path from them to everywhere or not. There we also have the concept of forest, which are like a union of different graphs that don't have a relation between them, or in this case with relation I mean a specific path. And finally the free trees, which, as I already mentioned, are graphs that they must not have a direction. That means it must be bidirectional each connection. They must be connected. That means that you can go from one node to every other node, and also it cannot contain cycles. The next trees are rooted trees, which are the ones that we're going to be working from now on. And rooted trees have different properties. The first one, which also gives its name, is the concept of the root. That means we have a special node which is called the root, and it's like the first node which starts the tree. We also have the concept of ancestor and descendant, which means that for every node it's related to the previous level by being its ancestor, and it can have up to several descendants. The exception with this that we have already seen is the root node, that it does not have any ascendant. Similar to this, we have the concept of parent and child, which basically, given a node, its parent is its ancestor, and its child or their children are the nodes that go from there. In this case, C has a single child, and for example, E would have two childs. Another family relationship is the concept of siblings, that are several nodes that share the same parent. In this case, H and I would be siblings because both of them have the node E as parent. We also have the concept of leaf, which is kind of like the opposite of the root, which basically are all nodes that do not have any children. There's also the concept of the degree of the tree, which is related to the number of levels. The depth of of the tree, which is for each node, its depth, it's going from the root to where that tree is located. Also the concept of height, which is kind of like the opposite, from there to the first leaf. So here would be going down, and the total height of the tree would be the same, but starting from the root. And now we are going to move on to how to traverse tree. We are going to study several algorithms. The first one being the pre-order algorithm, in which what we are going to do is first we are going to visit each node, its root, and then making recursive calls to its children. So as always, we are going to start with the root. So we visited first the root. That's why the result starts with the node A, and make the first recursive call to the first children going from left to right. We visited the children, make a new recursion, visit that child, and since the child is already a leaf, that means recursion has stopped and we need to go back up. We go back to B and continue the recursive call to the next child. In this case, that's E. We visit E and again start the recursion, visit H, go back up, back down E, and go back, 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 and we will move to the next part, and so on and so forth until we have visited every node. The next algorithm is in order, and in this case we are going to visit first the left child, then the node, and then the rest of the childs. So as always, we start with the root, recursive call to its leftmost child. Again, since it's not a leaf, make a new call. Now we have found a leaf, so we visit the leaf. That's why the result starts with D. And now we go back up. After going back up, the next step is visiting the node. So now we visit the node B and start the recursion with the following child. In this case is this one, and once more left child, since it's a leaf, we visit it. Up, we visit the node, and the last one, I, we visit it and start going back up. Up, we visit A and continue recursion. Now what happens here? We have mentioned that we start making the recursion call with the left child. In this case, since C does not have a left child, then there's no recursion call, and we visit that node. That's why here we have C, and then we make the recursion to the other child. In this case, F. Same happens with F. There's no node, so we visit F and continue till we visit G, and we are done. Now we are going to see the post-order algorithm, in which first we are going to make the recursive calls, and then we are going to visit the root. So again, we start with node A and begin the recursion. From left to right, the first children, Then another recursion call. We have found a leaf, so we visit it, and that would be the first element. Go back up, continue the recursion. Down, left, leaf. Up, down, leaf. Up, since there are no more children, we visit A and go back up, and so on and so forth until all nodes have been visited. The next algorithm is the level order, which basically we're going to respect the depth of the tree and going there from left to A. That means we are going to make a division on the tree by levels and go from left to right. In this case, this would be the first to visit, until we have visited everyone. Well, now let's move on to binary trees, which are a special kind of rooted trees, which have the particularity of having at most 2 children per parent, and those children are known as left child and right child, which actually is the example that we have been working on. So that means that each node has at most 2 nodes, which are the left child and the right child, and also even if there is one of them child is missing, we are going to be considering still as left or right. In this case, node C only have a right child, and the left child could be missing. Binary trees have several properties, which we can compute the maximum number of nodes at a given depth by operating 2 power the number of the depth. Similarly, given the height, we can compute which is the maximum nodes that that tree would have. The same with internal nodes, and also the maximum number of leaves. So that's everything from now. Thank you.